So today I want to show you how to perform a search, specifically a full text search in PostgreSQL. I've got this table at question called searchable job. So it's a normal job application which consists of many classic things like title, ID, description, and so on. If I click on it, I'll give you some preview. There are just over 5,000 records in this table. And by the way, I'm using IntelliJ Data Grid plugin for this functionality. So let's say I'd like to find all of the job applications which contain a word developer in it. I could write a simple script which uses like or I like construct in Postgres. Let's say something as simple as this. So it does work. Let me just limit this by title. As you can see, it does work, but it takes quite a bit of time to execute this query. It's about 527 milliseconds, and as you can imagine, as the number of rows will grow, this number will be easily represented in seconds rather than milliseconds. So we need something better than that. And in PostgreSQL, there is a structure called a vector and a function called toTsVector, which can take a string as an input and split it in words. So for example, if I write a query, select title and toTsVector, specifying a language, we will get something like this. So as you can see, the title software developer was split into a vector, develop, and software, and the same for the other titles. And the words you see in a vector, like develop and software, it's not actually a bug. It's the process known as tokenization. So it's basically a normalized token so that different forms of the same word are made alike. Therefore, if this word would be developer or developers, it would still transform to developed, and so on and so on. This should kind of give you a hint that we can create some sort of index on the title and on a description field. Of course, we want to search on title and description, therefore we need to create some searchable field, which is a concatenation of title and description, tokenized using this TSVector structure. Using a query similar to this, I will select title and description, and then concatenate title and description together, and because toTsVector is sensitive to nulls, I will coalesce it to an empty string, which will generate similar to this. And for convenience here, I'll just wrap it in a common table expression. So I will create a virtual table called SRC with 3 columns, title, description, and FTS, standing for full text search, which means that now I can search on FTS column rather than title and description separately. And to search, I can use a where operator with another Postgre function called toTsQuery, which essentially creates a query on top of the vector structure. And if I run it, you'll see that only the rows containing developer in either title or description are returned. However, it still takes ages for the query to execute. It's 729 milliseconds, which is somewhat slower than using a dumb full-text search with I like. And this is because this query will build the search vector every time you execute the query. So it's basically not worth it. However, what I can do now is create something called a generated column inside searchable job table. Let's call it FTS as well, passing the same expression we've just used before. You can see that FTS is added to the searchable job table, and if I have a look at it, it contains the vectorized form of title and description, which means that now I can perform search on the FTS column instead of creating vectors every time I query. So let's do that. Now when I search for a developer title inside searchable job, I can just use FTS column as a source and it returns me the results. But as you can see, the execution still takes over 500 milliseconds, which is almost the same as I like search. But this is only because we are still searching the entire table in a really dumb way, but using slightly more complicated data structures. What it will give us is probably more quality search because it will match all the variations of the word because our column is vectorized and the words are normalized, but still performance-wise, it really sucks. So the natural next step, I would say, would be to create an index on top of the FTS column. And to do that, I can use something called the gin index, pass the FTS column as a source, and run this. The index in itself doesn't even take that much time. It's about the same time as performing the query. And now, let's see what happens if I query the searchable job for a developer. Well, as you can see, the time is already cut almost in two. Well, it's only 5,000 rows, so it's understandable. But believe me, when the number of records grow, this time will be exponentially faster. Also, you can't do queries like this. Developer and Python, for instance. I mean, if you would try to do something like that, you would need to rewrite the expression and make it more complicated to something like this, which becomes really dirty. But also what TS Vector allows us to do is something like ranking the results. So I have created an index here on concatenated title and description, but in real life, I think title has a higher rank in search than description. At the moment, we are not utilizing this, and I don't know how you would utilize it with I like, to be honest. But with Postgres TS Vector, you can apply a ranking function called setWeight. So instead of creating an index this way, I would create it the following way, where I would assign weight of A to title and weight of B to description. So let's create this index instead. Of course, FTS index already exists, so let me just drop it quickly. Actually, I need to drop the entire column, not just an index. Recreate column with different ranks, and then if I have a look at this column, you'll see that we have ranking applied to every word A and B. So 7 for B, 7 for B, (3A) and so on. Recreate the index, check that the search still works, and it's all fine, same timing as well. Then, so how do I see the rank of each search query? So to create a rank, I will need to create another column based on my query. So I will move out the query to the from clause and call it Q. Check this still works, that's fine. And use a function called tsRankCD, which accepts a vector and a query and produces the search rank. So when I run it now, you can see that our search also has a rank in here. Therefore, I can even order this query results by descending rank. So you can see, as expected, the jobs which are appearing with the highest rank have Python developer in them. And if we scroll down, you can see that some jobs, they don't even mention Python in the title, but it does mention it somewhere in the description, therefore it is returned with the lower rank. And some jobs don't even mention anything similar to Python developer. It has a developer somewhere in the description, nothing in the title, I'm not even sure it contains Python word in it. And you can see that the search query timing is still the same. It's 400 and something milliseconds, and that's on a cold run. So this time changes all the time. So that's how you can speed up full text search queries in PostgreSQL using TS Vector and TS Query.